What's going on, Algebra Bros? It's Mr. C here, and in this video I'd like to recap some of the tweaks that we make to the library functions, or functions in general, which have the effect of transforming the graph of that function. So here I have kind of a general version of the format of a modified library function. And the first thing I want to do is just point out that the library function is represented by f of, okay, and I'll talk about the inside part here, x plus h. So I would like us to just be with the understanding that this represents whatever library function we're using to construct the function corresponding to a verbal description of transformations. Now, let's talk about these verbal descriptions that you may encounter. So a function will be provided to you, one that isn't modified according to the described transformations. So you'll start with that, and if there's any verbiage saying that there's going to be a vertical stretch or a vertical compression, that means you're going to have to insert a value for a, and that a is right in front of the library function. So a will either stretch or compress your function's graph. I'll indicate that. And keep in mind, another word for compress is shrink, which that's what I'm going to need to see after all this. So if there's any verbiage regarding stretching or shrinking of the graph, or stretching and compressing of the graph, you're going to want to put a number, the number that they provide, in front of your library function. If there's an indication that there's an x-axis reflection, then you're going to need a negative sign in front of that value of a. So placing a negative there will force your graph to do an x-axis reflection. Now keep in mind, it is possible to do a y-axis reflection, in which case you would want to insert a negative in front of the variable x in your library function. Now sometimes that will affect the horizontal shift, okay? In which case, to get the true direction of your horizontal shift, you'd want to factor a negative out from both terms, from the expression inside of the library function. I'm going to go ahead and get rid of that negative though, just to help out with this next part. So speaking of the inside of the library function, we could have expressions such as x plus h or x minus h, but regardless, anytime we're doing addition or subtraction directly to x, this would be inside of the grouping symbols, by the way, that indicates a horizontal shift. So if there's some verbiage saying that the graph needs to shift left or shift right, it means you're going to need a specific value for h. So h helps us with the horizontal shift. And remember, with the horizontal shift, it's best to think backwards or think opposite. And by that I mean, if it says move right, natural inclination might be to assign h a positive value, but instead you should actually assign it a negative value. And if it says that your graph should shift left, you want to assign your value of h a positive. And at the tail end of all this is plus k, and recall that adding or subtracting a number at the tail end of the expression is what creates a vertical shift. So if there's any indication in the problem that the graph needs to move up or down, this is asking for a particular value of k. And if it asks, or if it states that the graph moves up, your k value should be positive. And if it says that the graph moves down, your k value should be negative. So that's more in line with intuition, which for this reason I say think normal. All right, and that's a quick recap of all the modifications that we could do to a library function. specifically for the skill of translating a verbal description of transformations into a specific function. Alright, well I hope you found this video helpful. If you have any questions, feel free to let me know. Otherwise, thanks for watching, and I'll see you in the next one, Algebros.